Myself, Dr. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the introduction of engineering mechanics, and let us discuss what are the course outcomes related to this course and what are the syllabus related to the module 1, module 2, module 3 and module 4. So here the course outcome 1 is related to the introduction to the engineering mechanics. That is the first module, and it is related to the course outcome of identify and unknown forces by FBD, free body diagrams to a given equilibrium force systems through mechanics laws and derived laws. And the syllabus related to introduction to engineering mechanics is classification of engineering mechanics and basic terminologies in mechanics and different laws of mechanics, that is triangle law of forces and parallelogram law of forces, and characteristics of a force and the system of the forces. The system of the forces means coplanar and non-coplanar forces. Under the coplanar force system, there are various types of various types of systems such as coplanar concurrent and parallel forces system and coplanar non-concurrent forces system, etc. And also the resolution of the forces. Under the resolution of forces, we are going to study how when the force acts on the body with certain angle, we have to resolve into horizontal and vertical components, and we'll apply the equilibrium conditions, the equilibrium of connected bodies here, and also we'll apply the FBDs, free body diagrams we're studying. If you want to apply the resolution of the forces, we need free body diagrams. What is a free body diagram? Free body diagram is the combination of action and reaction forces which represents on body by removing the supports. Then that body diagram is known as a free body diagram. After drawing the free body diagram, we'll apply equilibrium forces. The equilibrium conditions are sigma fx equal to 0, sigma fy equal to 0 and sigma m equal to 0. What is sigma f suffix x equal to 0? The sigma f suffix x equal to 0, the meaning is that algebraic sum of all horizontal forces, that is in direction of the x, equal to 0. Here the key word is algebraic sum. The algebraic sum means it can become a positive or negative terms it may be there inside the equation. That's why it is known as the algebraic sum. So sigma fx equal to 0 and sigma fy equal to 0 meaning is that algebraic sum of all vertical forces. The vertical forces, it can be vertically upward and vertically downwards. So this algebraic sum, we'll consider it when the positive force, upward force, considered as a positive, and downward force, vertically downward, is considered as a negative. These positive and negative terms will be there in that equation. That's why it is known as algebraic sum. So algebraic sum of all vertical forces equal to 0. And the third equation is sigma m equal to 0. What is sigma capital M equal to 0? That means algebraic sum of all moment forces, any arbitrary point equal to 0. Again here there are two types of moments. One is clockwise movement, another one is anti-clockwise movement. We consider clockwise movement as positive and anti-clockwise movement is negative. Then the sum, the clockwise and anti-clockwise combination, sum will be there. That's known as algebraic sum of we are talking about movements. That's the movement about any arbitrary point equal to 0. After drawing the free body diagram, we'll apply these equilibrium conditions in order to find out the resultant forces on the system. Now here there is another, it's called Varignon's theorem, and the couple, and also resolution of force into a force and a couple. So they are all considered on a system of static system. We don't consider a dynamic system. These are all statics, comes under the category of when the body is under rest or at rest. We'll consider. Suppose the person is sitting on a table. This load is acting vertically downwards, passing through the center of gravity of the table. Then we'll consider then how the reactions are taking place and what is the resultant force. So what is the importance of this module 1? This module 1 is very important in order to do the static analysis, static force analysis. So here what is the application of this module 1? The application is that we'll study here in engineering mechanics, but the application is in strength of materials to find out the forces, the resultant forces. This module 1 is highly important in the case of for strength of materials or solid mechanics. While calculating the forces, there also we here for doing static analysis. And in the case of kinematics of machines, or in the case of a theory of machine subject, there is a static force analysis. Again, we have to study the dynamic static, that is called static force analysis. Again, we have to study the free body diagrams of the 3 force members and 4 force members to do the static analysis part and find out the resultant forces of the mechanisms. Now here, and one more important is that this module 1 is very important in the case of to find out the resultant forces of dynamics of machines, not dynamics of design of machine elements. In the module, in the chapter of shafts, not only in the chapter of shafts, and in gears, in analysis of the gears, we will find out this. We'll apply these principles, especially equilibrium equations, to find out the resultant forces. Highly important. This topic is. And coming to the module 2 related to friction. Now here, the course outcome is interpret the static and dynamic friction laws for the equilibrium state of a wedge, ladder and screw jack. These are the application, the ladder and screw jack and wedge. These are the application of the principles, laws of friction. Now here, what is the static friction and dynamic friction? Or in the case of here, the kinetic and kinetic friction comes into the picture. So here, what are going to study? The law of friction force and angle of friction, angle of response and cone of friction, and types of frictions, limiting friction and static and dynamic friction. And applications are wedge friction, ladder friction, screw jack and differential screw jack. Now here, the friction is a highly frictional force, is highly important. Without friction, the person can't walk. Like there is a contact force between the surface of the earth and the body. If the friction coefficient of friction is 0, the person slides, he can't walk. So friction force is highly important for practical purposes. And if the car is standing on the floor, that means there is a frictional force. Otherwise, if the friction force is not there, then immediately slipping takes place. That means coefficient of friction equal to 0. If the person is slipping when he steps on the banana peel, that means the coefficient of friction is 0. That means the sliding taking place. So if the friction is there, we are able to walk due to friction. We are able to hold any weight without slipping. That is due to friction. So here, and if you are unscrewing the nuts and bolts with the help of the wrenches because of due to friction, so screw jack is having the ladder is able to stand on the floor at the same time on the surface due to friction. So we are going to study some of the applications of the frictional forces. And suppose in this figure there is a rope where there is a way here traveling the different weights due to friction, otherwise it slides down. Similarly, power transmission takes place or torque transmission takes place in the case of rope drives due to friction, and also in the case of chain drives, the transmission taking place due to friction. So while cycling, in the case of bicycle, if you are cycling, sometimes due to if there is a sprocket slipping takes place, the chain slips on the sprockets, that means the friction is very low because that slipping takes place. The friction grip is not sufficient, then there is no transmission of the torque. Now here, in the case of belt drives, the grip between the belt and the pulley is due to friction. Otherwise, if the friction is not there, the slipping takes place. That causes the poor transmission of the power. So here, and there are many various examples we can understand. If the friction is not there, then the slipping will occur. That's why friction is very important. That's why we introduced in this syllabus of engineering mechanics this laws of frictions and fundamentals of frictions and application of the frictional forces. We'll study in deep such a way that this knowledge is highly useful for studying of dynamics of design of machine elements and strength of materials, etc. courses. The next one is the next topic is related to subject is that centroid and center of gravity. So here, what is the course outcome is that identify the centroid and center of gravity for the simple and composite plane sections from the first principles. So under this category, we are going to study the center of gravity, centroid, difference between various centroid and center of gravity, and the centroid of determination of centroid of various simple plane figures, and also composite sections, and also center of gravity from first principles, and center of gravity of composite bodies. Here, the center of gravity are centroid. They're the similar terms, but the center of gravity are useful for three-dimensional or tubes, and whereas centroid is the term useful for plane figures. Now, in this figure, the plane is one of the here is attached. Here, the centroid is highly useful for balancing or for balancing purposes. If you are holding any book, or the students are used to rotate the book by keeping the finger at the one point of contact. Unless it is the point of contact is not the centroid or center of gravity that book, what will happen is there will be unbalancing force takes place. That's why here the centroid and center of gravity concepts are highly useful for in the case of for studying the balancing or unbalanced forces for the subject for the course of dynamics of machines. And also the centroid and center of gravity is highly useful for calculating the moment of inertias. There are two types of moment of inertia. That is area moment of inertia. Another one is mass moment of inertia. Here, in the case of area moment of inertia, why it is useful for area moment of inertia for using the for applying in the case of parallel axis theorem. The parallel axis theorem, Ix equal to Ig plus A times bar x bar y square. Ij, okay, where this Ij is the center of gravity, the centroidal point is highly useful, so that to calculate the moment of inertias of different sections. So that's why it is highly useful to in the case of strength of materials course. So where we have to calculate the area moment of inertia, that is BD by 12 for rectangular section. So, and for circular section, the area moment of inertia, that is Igxx equal to pi d power 4 by 64. So, this here, why it is the passing, we need unless and until location of the neutral axis can be found out by using the concepts of the centroid and center of gravity of the strength of materials. So, it is the concepts of centroid and center of gravity is highly useful and very simple to understand it. So to find out the centroid of various sections, suppose if we consider there is a rectangle or square section, it is having a side of B. The square section, all sides are B. What is the centroid position? It is a B by 2, and also it is from here B by 2, and from alright, here for a rectangular section, suppose it is D and it is B, width is B. What is the position of the centroid? Centroid from here, it is from here, that is a D by 2, and from here to here it is D by 2. So, for locating the neutral axis is passing through the centroidal point. So, for locating the neutral axis of the section, we need the centroidal position. So, location of the neutral axis, so we have to find out the centroid. So, it is for simple figures how to find out the centroidal position for composite sections, for example, it is denoted by bar x and bar y, the coordinate of system. The CZ, this bar x and bar y. So it comes, bar x comes A1 x1 plus A1 bar x equal to A1 x1 plus A2 x2 and so on by A1 plus A2. There is bar y, that is A1 y1 plus A2 y2 and so on by, that is A1 plus A2. So that is, you can write sigma ay by, this is I equal to sigma ai yi, sigma ai yi, I equal to 1 to n by sigma ai, that is also I equal to 1 to n. The point is that here the bar x and bar y are the coordinates of the centroidal position or center of gravity position of the composite section. Next, it is related to the Bloom's taxonomy level for centroid and center of gravity apply level, and the friction also comes under here. The interpretation, understand mentioned, but we are going to apply the laws of friction, and identify is related to analyze. So here these are the Bloom's taxonomy levels. Let us come to course outcome 4, that is the moment of inertia. So the concepts of moment of inertia is highly useful to find out, where we find out the shear forces and bending moment calculations, this moment of inertia topic. I will explain in detail level. Let me discuss about what is the course outcome. So here they calculate the moment of inertia and mass moment of inertia of a simple plane figures and spheres from the first principles. Now under that we are going to study the moment of inertia, that is called area moment of inertia. Here the moment of inertia means nothing but only that area moment of inertia. We are not going to study the mass moment of inertia. So the area moment of inertia and also polar moment of inertia, radius of gyrations, parallel axis theorem and perpendicular axis theorem, and also it is mentioned mass moment of inertia. And the moment of inertia means there are two types: area moment of inertia, mass moment of inertia. This mass moment of inertia concepts is highly useful to find in the case of studying the analysis or design of the shafts and design of the crankshaft, etc. Their mass moment of inertia, that is Ig, that is the unit for mass moment of inertia is kg meter square. This is the units of mass moment of inertia. Whereas for area moment of inertia, unit is mm per 4 or meter per 4. Alright, in this manner we are going to study different theorems. Now here, what is the importance of this module? Why should we study? Where it will be useful in the coming semesters? Highly useful for strength of materials and also dynamics of machines and design of machine members and also vibrations. This mass moment of inertia and area moment of inertia. So where it will be useful, yes, let's give a glance. Don't get confusion. It's not so tough, but you understand. In the case of strength of materials, that is the simple bending theorem, a theory of pure bending, that is m by I equal to sigma by y equal to E by R. What is this I? I is the area moment of inertia of the section. If it is a rectangle, area moment of inertia for that rectangular section. If it is triangular section, the beams, the theory of simple bending, the pure bending, m by I, where it is useful, the concepts of this moment of inertia. That's why Indian mechanics is highly useful for mechanical engineers, aeronautical engineers, and also civil engineering people. One should not neglect. If you are thorough in engineering mechanics, you can crack any type of question from the concepts of engineering mechanics. It can be related to the coming semester courses like strength of materials, or problems are related to any question if you have thorough in concepts. This is the basic foundation course for civil engineers, mechanical engineers, and aeronautical engineering people. It is completely structurally related, and also for mechanical people, the machine designs related branch people highly useful. And you have the thorough concepts of design concepts. This design knowledge, basic concept, very strong. Then you can interpret more and more in by cracking the problems. And this is for theory of bending. You may ask, what is next? Is it only this much importance? Yes, no. There is further more. Let us begin with that is FA. What is the shear force? Tau equal to FA y bar by IB. The shear stress distribution when the load applied on the beams, not only bending moment, bending stress, the shear stresses also will be developed. How to calculate those shear stress analysis? The shear stress analysis that from the formula that FA y bar by IB. What is bar y? This bar y comes from where? Centroid. The centroid from vertical distance of central distance and vertical distance of centroid. What is I? This I is again area moment of inertia. Again, how to find out? For simple cross sections, if it is the B and it is a D parallel to x-axis, the neutral axis IXX equal to B times BD cube by 12. Alright. And if it is the composite sections, if it is the I section, what about IXX? The sum of again section 1, section 2, section 3. We have to apply the parallel axis theorem because the axes are parallel. We want centroidal axis. So we have to find out the centroid. If you want to calculate or determine the area moment of inertia, pass parallel to the x-axis. The neutral axis is parallel to the axis x. Then what will happen here? We have to find out first the centroid of the I section. Various sections of beams will be there. C section, H section, I section, T section. Alright. So for those sections, first in order to find out the area moment of inertia of a particular section, before that the prerequisite is known, the centroid value should be known. That means you have to apply the centroid concepts. After applying the centroid concepts, you have to locate the central axis. That central axis determines that is the neutral axis. That after the centroid axis location, we have to apply the parallel axis theorem to find out the area moment of inertia of a particular section. Here it is the I section. That's why first we have to locate the centroid by using the concept of centroid. That is the module 3. Am I right? Yes, module 3. And after that, applying the centroid concepts, you have to go for, we have to apply the parallel axis theorem. After applying the parallel axis theorem, by applying parallel axis theorem, you can find out the moment of inertia. That moment of inertia value is highly useful to find out the shear stress, the variation of the shear stress across the section of the beam. Okay. In the case of civil structure, there are various types of beams are there. One is cantilever beam, another one is the simply supported beam. Cantilever beam means one end is fixed, one beam, and other end is free. And if you construct a small wall, which is like a balcony, the people will do and the chit-chatting business on the apartments here. The cantilever beam is required. There is another type of beams. If you consider the columns and beams, there is simply supported beam. Simply supported means two ends will be supported. Yeah, it is the beam having a simply supported here. When there is a house is there, apartment, with a combination of what? The whole apartment stands on beams and columns. Alright? So the beam should be supported. The beam section is not in proper direction. Then immediately collapse takes place. There is a lot of damage. So this analysis, the variation of the shear stress, in order to do the shear stress analysis and bending stress analysis, this moment of inertia, the parameter of moment of inertia is highly useful for designing the buildings or for constructing the buildings and heavy structures. And one more thing, the centroid is highly important. When coplanar concurrent forces are acting on any body, Then in order to find out apply the equilibrium conditions, our assumption is that all forces are passing through at one particular point. So highly useful to find out to calculate or to do shear stress variations or to calculate shear stress variations across the sections of the beam, and bending stress variations also across the section of the beam. This moment of inertia is highly useful. Coming to next part, that is called the dynamics part. So far we studied the statics. The engine mechanics is divided into two components. One is the statics part, another one is dynamics. The statics part is coming. What is the meaning of statics part? Means to find out the resultant forces, or to find out the coefficient of friction, and to find out centroid or a moment of inertia when the bodies are at rest. So here, the coming to statics part, the engineering fundamentals of engine mechanics modules: module 1, module 2, friction, module 3, centroid and center of gravity, module 4, moment of inertia. These are the 4 modules that comes under the category of statics part. Next, coming to part 2, that is dynamics part. Here, in the case of dynamics parts, again here one has to study what is kinematics and kinetics. Now here the dynamics part, we are going to study here particle dynamics and work. That is called under that. It is related to the Bloom's taxonomy level is applied. And what is the course outcome we mentioned here is that apply D'Alembert's principle to a dynamic equilibrium system by introducing the inertia force or knowing the acceleration and forces involved in the system. That's what here, that is the course outcome. And here the kinetics of rigid bodies, that is Newton's second law, D'Alembert's principle, and its applications in plane motion and connected bodies. Work done by a varying force, energy, power, work energy equation, and for translation, work done by a spring. So these are all the things we study the topics related to here module of that is particle dynamics and work. And what is the use of to study these concepts? Yes, dynamics of machines. These concepts are highly useful for dynamic force analysis. And also vibrations is the dynamics, it's a function of the time. And dynamics where here work done by a spring. And there we'll apply the Newton's second law and the D'Alembert's principle in order to find out or calculate the equilibrium equation or characteristic equation of motion of a spring mass system that comes under the category of mechanical vibrations. So to do vibration analysis, these concepts are highly important. And also free body diagrams for dynamic forces. And what we have to make it, the system is under equilibrium, dynamical equilibrium. We have to make it. That means we have to draw the free body diagram. And we have to apply the D'Alembert's principle such a way that we can write the equation, that is characteristic equation of a system. And again, in dynamics, there are single degree of freedom, 2 degree of freedom systems, multi-degree of freedom systems, and also infinite degree of freedom systems, where these things are useful, highly useful to crack or to solve those problems, dynamic problems. Next, finally, there is a course outcome 6 related to impulse, momentum, and mechanical vibrations. These are the impulse, momentum, and what is the course outcome here? Determine the governing equation for momentum and vibrational phenomenon of mechanical system by using energy principles for obtaining coefficient and circular frequency. It is not only obtaining coefficient, that is called stiffness, and also natural frequencies or equations. So what are the things in detailed concepts? The subtopics related to here to this module is that linear impulse and momentum, connected bodies, conservation of movement, loss conservation, and types of impact, and coefficient of restitution. And vibrations, what are the types, various types of vibrations, free vibrations, forced vibrations, and time period, what is the compound torsion pendulums. These are the basic concepts, but these concepts are highly useful to write the equation of motions of a single degree, 2 degree, multi-degree, and infinite degree of freedom systems. And here, these concepts are useful for, as we have studied, the dynamic forces, that is DOM, okay, and kinematics of machines and dynamics of machinery courses, and also mechanical vibrations. And for doing vibration analysis and dynamic analysis, these are the highly useful. And one more thing, very very important, is that impulse momentum equations highly useful for doing the crash analysis, finite element analysis in ANSYS workbench, that is software tools for designing the cars. While car design, you want to get crash worthy certificates, we need the data of crash analysis details. For that, these concepts are highly useful, the impulse and momentum. So this impulse and momentum, this impulse means when delta t tends to 0, yes, the time tends to 0, but it's not 0, the time tends to 0, the impulse. That means it acts very quickly. So that is under that loads. We'll study the analysis of the crash analysis of automobile components here, and also the vibrations. Here the car under various vibrations, how the body, is it possible to sustain at various vibrations, and that is random vibration system we are going to use here, is not linear vibrations, non-linear vibrations. The non-linear random vibration test is going to be conducted for any automobile vehicle or space shuttles or aeroplanes, helicopters, because these are under functions with the time, under dynamic forces. So the body or the machine or the structure should withstand at various dynamic forces, at various aerodynamic forces, at various random vibrations. So when the aeroplane is passing into the air, it is under the vibrations of aerodynamic forces in different directions. And the turbulence comes into the picture when the plane is passing through the turbulence at the 10,000 feet and at certain distance of 5 kilometers, 6 kilometers. Is the unpredictable things where the structure should withstand under those catastrophic climatic situations, environmental. So that type of things, those are called Adidaivika kleshas, which are caused by the klesha caused by the due to environmental effects. Okay, so that is due to because natural climatic conditions. When the structure is passing it, then the structure should withstand under various forces. For thus, we have to use these vibration testings. Under those vibrations, the machine is able to withstand those dynamic forces or not. Then if it is not, then we have to go for redesigning it. After that, we have to verify it, rectify it, and again we have to fabricate. Alright, these are the syllabus, and we have studied in detail level what is the purpose of each and every module of engineering mechanics. That's why engineering mechanics is highly important. If you're thorough in fundamentals of engineering mechanics, you're master. If you're a civil engineer, you're master in civil engineer, you will become master very quickly. So engineering mechanics is the basic foundation course for the branches of aeronautical engineering, mechanical engineering, and civil engineering. Alright, so let me conclude that in this session we have studied what is the introduction of engineering mechanics through the syllabus. There are 5 modules are there here. The first module is fundamentals of engineering mechanics. Second module is friction, that studies what is the principles of friction. And the third module is the centroid and center of gravity calculations. Fourth topic is the moment of inertia. And the next topic is that particle dynamics and work. And final module is that impulse momentum and mechanical vibrations. So we covered the statics, structural engineering, and the dynamics part of my vibrations, how it will be useful for doing dynamic analysis. So alright, and we'll study in detail level. So let us begin with the concepts of engine mechanics. So engine mechanics is a branch of science which deals with the behavior of the body when the body is at rest or in motion, or is at a statically condition or under dynamic condition. What are the forces? What is the behavior of the body? So, and it is a branch of science, it's the foundation of engineering, not only a branch of engineering, it's not only a branch of science, it's the foundation for engineering. So, for mechanical and aeronautical and civil engineers, that subject it is. Now, here the engine mechanics is divided into two parts. Number one, static part, and another one is dynamic parts. So, in this manner, we'll study more in detail. All right. Systematically, if you follow this course, you can crack a public service undertaking of the government of India. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.